All right, so we used to have this kind of bulb, and those round energy saving energy about 40, 60, 100 watts bulb. They are not actually energy saving bulbs. But these days, Ghana Energy Commission stopped the use of those bulbs. They are now used in the poultry farms. Okay. And those are the tungsten filaments, the incandescent bulbs. Okay. They are power rating or wattage so high, 40, 60, 100. Okay. And these are bulbs that produce light when heated. So some lighted bulbs or incandescent bulbs can also be put under this category. So incandescent sources of light are sources that produce light when heated, such as the sun, incandescent bulbs, burning firewood, candle, and some other sources. Then we have fluorescent sources of light. For fluorescent sources, they do not produce light as a result of it being heated. No. So firefly or fireflies falls under this category. Glowworm, and some electric fish. Some fishes also produce light. Some fishes also produce light naturally. Some sea fishes, such as electric fish. Okay, so the firefly, glowworm, electric fish, okay, can also be, and then some fluorescent lights such as the long fluorescent tubes also fall under these categories. So these are some categorization of lights. Please, any question? Okay. Light can be represented as a ray, just a ray. So when we are on a diagram, if we are to represent light, it is represented as a ray of light, a ray of light. And a ray of light is a bold line with an arrow at the middle or at the end. So this is what we mean by a ray of light. Several rays of light, more than one, two, and so on and so forth, are termed as beam of light. So if you are representing anything ray and you draw a bold line without this arrow, you are wrong. So take notes. Take notes. Please, any question? Okay. Now for rays of light, we have what we call convergent rays, convergent or converging rays or beam of light, divergent, and then parallel beam of light. These are parallel beam. The individual rays do not meet. So we can refer to this as parallel beam of light or rays. Converging rays. Converging rays comes from a source and then all converge at a point. So individual rays from a point and then converging at a common point. So we can represent this as converging rays. Then diverging. They are all from a point and then spread out. So these are diverging rays or lights. So we'll be using these terms so much under lights. Please, any question? All right. Then let's look at the plane mirror. We're actually going to look at reflection of light. Reflection of light. Then as we go through reflection of light, then we look at the plane mirror and then the spherical mirrors. Reflection of light. Or, you see, properties or characteristics of light. Let's discuss properties or characteristics of light. Light can exhibit so many characteristics or properties. One of it is that light can be reflected or can undergo reflection. Light can also undergo refraction. Light can also undergo diffraction. Light can also go through interference. And then light can also undergo polarization. So these are some characteristics of light. They can exhibit, or light can be reflected, refracted, diffracted, interfered, and then polarized. At your level, we have to take you through reflection, refraction, and some aspect of, we'll also go through this too, but this will be considered when we look at waves in physics. So let's look at what we mean by reflection. Reflection. What is reflection of light? What will you say about reflection of light? Yes, a volunteer to tell us something under reflection of light. Eva, can you hear me today? Eva. Eva and the microphone. Okay, Christine, over to you. Christine, tell us something about reflection of light.
Okay, I think that reflection of light is the bouncing back of light rays from a smooth, plain mirror.
Okay, that is okay. Bouncing back of light rays from a smooth plain mirror. Ella, your hand was up.
She said what I had in mind.
Pardon?
She said what I wanted to say, not the
So
exact meaning.
the wind was taken out of your sail.
Yes,
Okay, Eva, can you hear me? And can you speak? Eva. Oh, fine. Eva and your network. And speak to me. Tell me something about reflection of light. Your mic. Okay. Who want to mommy, share something on reflection with me. Mommy. Okay, so usually in fact, if I ask question, I want quick response. I don't want time wasting. So please, if you have something to say, be quick. So just as Christine said, when we talk about reflection of light, it's about the bouncing of light from a surface. So the bouncing back of light ray from a surface. Okay, from a surface. But let's look at the conditions necessary for reflection of light to take place. What factors do you think would affect the extent of reflection of light? Factors or conditions that must prevail for reflection of light to occur. Yes. Yes, factors. Aisha, give us one. Tiata, you also don't speak. I'll tell your mother. Aisha, conditions necessary for reflection of light to occur. Is Aisha there?
Please, yes, please.
Aisha, one.
The angle of incidence. Please,
Mm,
angle of incidence.
angle of incidence, Aisha. This is some stuffs and reflection, but I wouldn't consider that as a condition. More views. Asha has actually broken the ice for us. More views. Janice, you don't talk. Janice.
Mr. Dear, first one.
Go ahead. Conditions. Oh.
Said the nature of the surface.
The nature of the surface. Yes, the nature of the surface. Two. Eva, the nature of the surface, the nature of the surface is supreme. Because for your second point, if there is no light, there wouldn't be reflection. But the nature of the surface is a good condition. Two. Two. What condition would affect the extent of reflection. Janice, Janice, just
Yes.
share with us what you have on your mind. It's correct. Just share. Just say it.
Mr. Dear.
Mr. Janice. Hey, did I say Janice? Jasmine.
Eh,
The JJ names. Jasmine. Mame. Bafua.
Miss Adria, please. Miss
I'm
Adria,
listening. Go ahead.
please. I was thinking of see when the surface is, let's say,
So,
black, it's going to absorb. You see, some surfaces absorb the light,
yes.
and the polished surfaces will like reflect. So, yeah.
So how are you terming this? So
Miss Adria,
clearly,
please. I don't know how to state it.
okay, clearly this must be the nature of the material. Okay. One, you are talking about. So actually, the nature of the material must come first. The nature of the material is meaning, is the material solid, liquid, or gaseous? Then the color can also be talked about, and that is in line with what you are saying, Christine. If it's black, it cannot, the material color is black, it will absorb most light and then reflect just small. Because black bodies absorb or retain light, incident light. If the material is plain white, it would reflect more and absorb less. Okay. Then you bring in the nature of the surface. What is the nature of the surface of the material? Its smoothness, is it so smooth that the surface, okay, refers to where the light incidents? Is it incidenting at a very smooth surface or rough surface? If the surface is so smooth, well polished, and then painted or coated with a certain color, silver. So you see, mirror is just glass. If the back, you see, mirror is not so much different from louver blades. The mirror you use, especially you ladies, isn't different from louver blades. Okay, the only difference is that for this mirror, the surface is well smoothened, well polished, smooth. Then the back of it is coated with a certain substance or material, silver, so that the back is opaque. And silver has the ability to reflect, so it wouldn't allow the light to pass through, but it will reflect it. Okay, so you need to coat the back, meaning for mirror, if you don't coat the one side, it will just behave like louver blades. So these are the two. Jasmine, mute yourself before I mute you. So The nature of the material, is the material solid, is the material liquid or gaseous, and the state of the color. Okay, then the nature of the surface. Okay, is it well polished or is it rough? The point is that if the surface is rough, reflection would occur, but you will not see it because the reflected rays will be scattered. If the reflected rays are reflected in a certain pattern, that is where you will see that, oh, reflection has actually occurred. So when I incident put on beam of light, torchlight, it will reflect and hit somewhere. Okay, and I can see the reflected rays because this surface is well polished and this is an opaque material. So these are the key factors that determines extent of reflection. Please, any question? Let's quickly look at types of reflection. Types of reflection. And the types of reflection, we have two main aspects or kinds of reflection. We have what we term as regular or specular reflection. We have one regular or specular reflection, and two, we have irregular or diffused reflection. Janice,
Mr. Dia, please, I can't see well. The light is on the board.
oh, this is where there is reflection. Use the term. Janice, use the term. Reflection of light. This is reflection. Reflection. As for the types of, you can see regular or specular reflection. Two, irregular or diffuse reflection. Janice, are you okay?
Yes, please.
Now, regular reflection occurs on smooth surfaces. So regular reflection occurs on smooth surfaces such as mirrors, or here let me be specific, plane mirrors or plane mirror, well polished surfaces, well polished surfaces such as walls, tiled floors, and calm water surface. So these are what we are referring to as well-polished surfaces. Okay, plane mirror, the surface of plane mirror wall polish surface such as walls, tile floors, and then also occurs on calm water surfaces. Now, reflection is such that, in fact, whenever light travels from one medium, what we are terming as homogeneous medium, homogeneous. If the material is homogeneous, then it means it is of the same atomic composition. So air molecules, when light is passing through from air to maybe water, when the light is moving through air, we say that the light is moving through a homogeneous medium because from the starting point to the boundary, the light is moving through only air particles or molecules. And so because the first medium is only about air molecules, we say that it is passing through homogeneous medium. The moment it leaves the air and then comes into water, it is from one medium to another. But so long as its path is within the same medium, we say air is passing through a homogeneous medium, one atom medium. So whenever light travels through a homogeneous medium, its path will never change. The moment it enters into another medium or heterogeneous medium, mixed, then the path will change. Okay, so light does not reflect or deviate path when it is moving through a homogeneous medium. Take note. So in regular reflection, this is what happens. There should be a smooth surface, such as in optics or light, smooth surface is represented as even cross-sectional something with this showing a coated end. It can be a mirror, coated surface. So where we have these ciliated lines represent the coated surface. This other part represents the well smooth or smoothing surface. Please, are we there? Okay, so in regular reflection, light incident on a surface in a beam. So we have the incident beam. We have the incident beam. Then, so this is the incident rays. Then the light is also reflected in that orderly manner. So the beam of light is orderly, or rays is orderly, and then the reflected rays is also in that orderly manner. So incident beam and then reflected beam. I just earlier said if you are drawing a ray and there is no arrow, you are wrong. So take note. Okay, so these are the reflected rays or beam of light. So in regular reflection, it occurs on well-polished, smooth surfaces. Example stated. Now what happens? The incident light, okay, incident on the mirror in that orderly or well-patterned manner. And then the reflected beam also, or rays are also reflected in that orderly or patterned manner. So if you are to describe regular reflection or specular reflection, you must talk about the nature of the surface. You must also talk about the pattern of the incident beam and then the reflected beam. Now, whenever regular reflection occurs, it results in the formation of images. So regular reflection results in the formation of images. That is why if you visit well-polished offices, you see your image on the ground. That is why if you look at yourself in a mirror, you see your image in a mirror. That is why if you look at yourself, okay, in a calmed water surface or calmed water, you see your image, okay, in the water. So wherever regular reflection occurs, there is a formation of virtual image. There is a formation of image, but mostly the image formed is, in all cases, the image formed is virtual. Please, is there any question? Then let's look at the other kind of reflection. Irregular or diffused reflection. Can somebody help me? Can you brainstorm, think through something and share with us? If regular reflection is like this, what do you think irregular reflection would also look like? Anybody to share something with us? Irregular. Okay, Ella.
So please, I think the rays of the irregular reflection is going to be scattered.
I said when you are describing this, you need to talk about, okay, Jasmine want to say something. Go, Jasmine.
Sadia, please, I think irregular reflection occurs when light rays are struck on uneven surfaces.
Even surfaces.
Uneven
Uneven.
surfaces. Yeah.
Okay. More views. Please, if any of you also has something to add, you can. Anything to add? Ella. Okay, Ella.
Sir, please, oh, so can you say that the rays are reflected on rough surfaces and then the rays scatter in like different directions?
You are right. So yes, here the surface, as Yasmin and Ella said, must be uneven. Look at irregular, the surface is smooth, meaning even cross-sectional area. But for irregular reflection, the surface is rough or uneven. So in drawing this, you draw some logarithmic lines to represent the rough surface. Now, what happens is that the incident beam is regular. The incident beam regular. But the reflected beam irregular. So we have regular incident beam, incident rays, but the reflected rays are scattered because of the uneven nature. Because of the uneven nature of the surface. So scattered reflected rays. These are the reflected rays that are scattered. So this is what happens when rays, beam of light or rays incident on rough walls, the floor. You see, that's the light from the sun, the sunlight comes in millions of rays. But when they hit the floor, the nature of objects on the surface of the floor uneven. We have fine sand, we have small stones, we have rocks, we have buildings, we have Janice, we have Mistadria, we have Christine, we have bicycles, different. We have trees, name them all over. Now, because of this uneven surface on this, all materials on the surface of the earth, the beam of rays from the sun reflects in different angles. The reason for which when light incidents on rough surface, there is no image formed. So even though we receive millions of well-patterned rays from the sun, it doesn't form image of virtual image on the ground because the nature of this reflection is irregular because the surface of the earth is uneven. So irregular reflection does not produce images, but it has some advantages. One of the advantages is that its irregular reflection aids even distribution evenly distribution of light energy from the sun because of the scattered nature of the reflected rays. Unless you are hiding in a place where there isn't any hole or opening, then light would hardly reach you. But if there is a hole or an opening, no matter where you hide, light from the sun will be there. Class, true or false? So that is why you can be hiding under a canopy of a tree. Okay, canopy. But once there is some opening, light will still reach you, and you'll be able to see at wherever you are hidden. Due to irregular surface of the earth, and so the light from the sun is scattered. Okay, the reflected ray is or rays are scattered, and so light will be able to reach you no matter where you are hiding. 2, you see, the sun produces 2 things: light and heat. So it also aids even distribution of heat from the sun, heat energy from the sun. Okay, so the moment the beam of rays incident on the uneven surface of the earth, where irrespective of wherever you are, you can get or receive heat energy from the sun to heat our bodies up. So that irregular reflection also has its own positives. Any question? Any question? All right. All right. So this is what happens. Now, let's look at laws of reflection. The laws of reflection. You went through the laws of reflection in JHS. You went through the laws of reflection in JHS. Rachel.
Sir,
Share with us one of the laws of reflection. One of the laws of reflection. 1. Oh, Rachel.
sir,
Give us one of the laws of reflection, if you remember.
okay. One of the laws states that
Mhm,
the incident ray, the
mhm,
reflected ray, and the normal to the surface of the mirror
mhm.
all lie in the plane.
Okay, thank you. So the incident ray, reflected ray, and the normal at the point of incidence, and the normal at the point of incidence all lie at the same plane. Thank you. So all that we are saying is that whether the surface is rough or smooth, a normal is an imaginary line. This imaginary line is called normal because it is always perpendicular to the surface. So a perpendicular point can also be termed as a normal. It is normally to the, so if this is the surface, an imaginary line which is always perpendicular to the surface can be drawn. And this imaginary perpendicular line is what we are referring to as a normal. So when you draw this line, and then the incident ray would act at where the normal is. So the incident ray, the reflected ray, and the normal at the point of, the normal is at the point of incidence, all lie in the same plane. So here, in some books will state that all lie in the same plane or all lie in the same place or plane. This is the vertical plane. So they are all along the vertical plane or place. So that's the first law. The second law. What's the second law of reflection? Christine.
Okay. The angle of incidence is equal to the angle of reflection.
So angle of incidence is equal to the angle of reflection. Christine, how do we measure angle of incidence? How do we measure the angle of incidence? Christine.
Let's go.
How do we measure the angle of incidence? Okay, maybe Christine. Go ahead.
Since the normal is perpendicular, I mean it's 90 degrees. So I think when you add the angle of incidence to the angle of reflection, you're supposed to get 90 degrees.
Christine, I won't buy it. So if OAB, it means for angle of incidence, we are referring to angle OAN. OAN. Let's angle at A here. So Christine, we measure angle of incidence from the normal to the incidence ray. So if using the protractor, you put your 90-degree mark on the protractor on the normal and then read anti-clockwise. So angle of incidence is the angle between the normal and the incident ray. Class, are you okay?
Yes, please.
So this is the reflected ray. The reflected angle of reflection is also measured from the normal to the reflected ray. So this angle NAB. So angle of reflection angle NAB is the angle of reflection. So the reason why in ray diagrams you need to have your normal is that these angles are measured from the angle of incidence and the angle of reflection are always measured from the normal. Okay, there is this angle which is the angle between the mirror, if this is a mirror, the mirror and then the incident ray. This angle is known as the glancing angle. The glancing angle is the angle between the mirror and the incident ray. Glancing angle. So we'll be talking about them as we move on in. So the rule says that angle of incidence is always equal to the angle of reflection. So practicals or experiments, and then theory reveals that these two angles are always approximately the same. You'll be doing this in your physics practicals to confirm this law that angle of incidence is equal to angle of reflection. So practically or theoretically, they are the same. Now, look at the two types of reflection, regular and irregular. Whether we are talking about irregular reflection or regular reflection, each of the rays and their corresponding reflected rays obey the law of reflection. This is what I'm saying. Assuming we are talking about reflection on an uneven surface. So let me indicate my normal. If there's a point perpendicular to this is my normal. So when you incident light here, this is the incident ray. This angle is always equal to this angle. So whether the reflection is diffused or regular, it obeys the law of reflection, and that is incident ray, normal at the point of incident, and then the reflected ray all lie in the same plane. 2, angle of incidence must be equal to angle of reflection. So these laws are obeyed whether the reflection is regular or irregular. Please, any question? Janice, any question?
No, please.
Okay. Then let's look at the plane mirror. Reflection of light in a plane mirror.
Hey, dear, please, I want to draw the image.
Okay, go ahead. But be careful not to draw me in addition to what you are drawing.
Yes, please.
The plane mirror. The plane mirror is just plane, as its name, meaning plane because the surface is even cross-sectional area. The reason for which we term it as plane mirror. So we look at reflection of light in plane mirror. And then characteristics of images. Janice, are you done? Janice.
Yes, please.
The plane mirror. So Plane mirror is plane. The cross-sectional area is the same. So one side, well-polished surface, and the other side is coated with silver. And that makes the mirror opaque so that it wouldn't be transparent. So this is the coated surface. Okay. Now so this is a representation of the plane mirror. This is a horizontal one. It can be drawn as a vertical. The choice is yours. Now let's discuss the characteristics of images formed in a plane mirror. When you look at yourself in a plane mirror, can you describe the nature of the image you see? Yes, you are a fan of using the plane mirror. Even in classrooms, you have mirror under your desk and so on and so forth. So let's discuss the characteristics of images formed in a plane mirror. We are 10, so we are going to give 9. You are 9. Let's start from Aisha. Aisha, give us one description of the image you see when you look at yourself in the plane mirror. Okay, Janice wants to start it. Janice.
Please, the image is virtual.
Image is virtual. What do you mean, Janice? What do you mean by the image being virtual?
It's not real.
What do you mean by not real?
It's formed on a surface.
Ah. Okay, so if an image is virtual, what does it mean? It cannot be. Or Ella, you want to say something?
It cannot be touched.
No, please, I
Uh,
want to
it cannot be
um
touched,
another.
meaning it cannot be formed on a screen. Okay, so virtual images cannot be formed on a screen. Yeah, people are rushing to answer because they are the wind will be taken out of their sail. Okay, Ella.
Sir, please, the distance from the object to the mirror is the same as the distance from the image to the mirror.
Thank you. So image distance, object distance equals image distance. Okay, Yasmin.
Cedra, please, is the same size as the object, which is here.
So object size the same as the image size. Aisha.
Please, the
Aisha's,
image is
the image is. Aisha, your line is breaking.
please, the image is upright.
The image is upright. Aisha, what do you mean? What do you mean by the image is upright?
It is erect.
What do you mean by it is erect?
Mm.
uh, okay, what you mean is that the orientation, the head foot orientation of the image is the same as the head foot orientation of the objects. Okay, so you've talked about image is virtual, object distance equal to image distance, object height equal to image height, and then the image being erect. Do we have any more description of the image, nature of the image in a plane mirror? Mami, Rachel, Tiata, Eva, and then Christine. I'm waiting for you. Do we have any? Okay. The last one is that images formed in a plane mirror are always laterally inverted. Laterally inverted. Can somebody explain what I mean by lateral inversion? Can somebody explain what I mean by lateral inversion? Okay, meaning it is turned horizontally, laterally. Okay. Look at look at the illustration I'm going to make. When you visit the barbering salon, and then you look at the barber, it always appears as if he's using his right hand, it appears to you, the viewer, that he's using the left hand. So if he's a right-handed person, it will appear to you, the viewer, that he's using his left. As we speak, this is my right, but the image I see, okay, here appears as if it is my left. That is lateral inversion. So the image appears to be inverted horizontally. I don't know if you've made that observation of the barber before, where you visited the salon and looking at the barber, it appeared to you that he's using his left when he's a right-handed person. Have you made that observation before? Any of you?
Yes, please.
So that is lateral inversion. And images, okay, that appear in the plane mirror always looks as if it is laterally inverted. So when you look at the image form, your right hand appears to be your left hand. Your left hand appears to be your right hand. That is the nature of image. So these are the characteristics of images formed in a plane mirror. Now I've also seen some images formed in a plane mirror which always looks different from the object. There are some plane mirrors. You look at yourself and your head looks bigger in the mirror than your real self. Have you also made that observation before? Have you? Am I
Yes,
talking to
please.
somebody? So where you use a mirror and your head size in the mirror appeared bigger than your real self. In fact,
Yes,
it
please.
happens. It happens, but those are manufacturing defects. They are faults. Mirrors are not designed, okay, as such. Your head size must be the same. Mirrors that look like that are as a result of manufacturing defects or faults during manufacturing. Please, if you have any question, ask. Is there any question? Because it's 9 o'clock. All right. If no question, then this is where we draw the curtains on today's meeting. We'll continue with our physics. Today's Thursday. Okay, next week, Tuesday. Okay, good night to all of you. Take care. Please subscribe to my channel and share. Okay,
Yes.
as
Woo.
well, I'll be
Yes, please.
uploading the video. Subscribe and share. Okay, until
Yes, please.
next week Tuesday. This is why I draw the curtains on our meeting. In fact, good night and bye-bye to all of you.
Good night,
Bye,
Mr. Ejika.
Bye,
Bye-bye,
Mr.
Mr.
Ejika.
Ejika. Bye.
Oh.